Okay, when we are writing equations of lines, we need a few things, okay? What are some things that we need? You've written equations since Algebra 1 of lines. What do I need? Slope. I need slope. What else do I need? A point, right? Whether that point is a y-intercept, whether that point is just a point, I need some sort of point in order to write an equation of a line, okay? We are going to use point slope form. So y minus y1 is equal to m times x minus x1, if you forgot that. Okay. And then we also need to remember, if we're given a function and it says that we're going to use the power rule, we're finding the derivative, right? When I find the derivative of a point on a tangent line, that tells me the slope, right? When I find the derivative of a function at a certain point, that tells me what is the slope of that tangent line, right? So it says to write the equation of a tangent line to the function at this given point. So we're given this function and we have a point. So I have a point, now I just need to find the slope, right? So let's go ahead and use our power rule to find the derivative of this function. If I take the derivative of x, what do I get? 1. The derivative of negative 2x squared. This 2 comes down in front. Multiply it with that negative 2. I get negative 4x to the first power, which is just to the first, right? We don't have to write that. We can just write 4x. Okay, well, is that my slope at the point? No, that's the equation that I can use, right, to plug in a value to find out what the slope is. So let's do that. I'm going to plug in, to find my slope, I'm going to plug in 1, because that's my x value, into that function. So I've got 1 minus 4 times 1, which is negative 3. So I've got my slope, I've got a point. Can I write an equation now? Yes, I can. My equation here is y minus y1, which is negative 1, is equal to my slope of negative 3 times x minus 1. Oops, that was a bad square. That wasn't much better. Okay. Now again, in this class, you can just leave your answer like that. We do not need to do any algebra to make silly little mistakes to distribute the negatives, okay? The calculus has been done. We can be done for that problem, okay? If you do the simplifying, it's just going to make my life a little bit more difficult when I'm grading, personally, okay? So I'd prefer it if you left it like this somewhere on your paper so that I can check that answer, okay? All right, letter B here. I've got the equation of a line tangent to this function at a given value of x. This time I'm not given a y value for this function. How could I figure out what the y value is? Plug it in, right? I've given my function. If I plug in 1, I can get my y value, right? So f of 1 is 2 times the square root of 1, which just equals 2. Okay, so we have our point. Our point is 1, 2. Now we need to find the derivative, okay? So let's find the derivative of this function. In order to do that, we should probably write x to have a fractional exponent, yes? So this is the same as 2 times x to the 1/2 power, right? Okay, use your power rule to rewrite this, or not rewrite it, but to find actually the derivative. I should not have put in this derivative symbol here yet because I didn't actually find it. I just rewrote it, okay? Find the derivative of this function by using your power rule, and then check with the person next to you. All right, did we all get 1 over the square root of x, or x to the negative 1/2? Yes? Okie dokes. Now I've got to find my slope, because I have a point, but I need my slope. I've got my derivative function, so all I have to do is plug in 1 for x. So I've got 1 over the square root of 1, which is 1. So our equation of our line is y minus 2 is equal to our slope times x minus 1. And that is your final answer. Okay, so for writing tangent lines, you have to have a point from your original function. If you're not given the y value, you can find it. And then after you find the derivative, plug in your x value, evaluate it to find what your slope is at that point, okay? Now, this next example here says, find locations of horizontal tangent lines. So we're trying to figure out what point or what x value is this graph going to have a horizontal tangent line. Well, think really quick, what does this function of x squared plus 4x plus 1 look like? What does an x squared function look like? It's a parabola, right? So if I have a parabola, where is it going to be equal, or sorry, where is it going to have a horizontal line if it's tangent?
0.
At the bottom, right? Whatever that vertex is, right? This creates a horizontal line there, right? Even though it kind of looks a little slanted. A horizontal line, which means has a slope of 0, right? A horizontal line has a slope of 0. So basically, no matter what function we're given, if I had a function like this, I'm looking at what points is my slope 0, okay? So for this equation, how many points are there going to be? Just one. How are we going to find it? I don't just plug in 0. I need to figure out my derivative so that I can but I can set that equal to 0, right? Because the derivative of a function tells me the slope at a certain point. So if I want the slope to be 0, I just have to solve that, okay? So let's find the derivative of this function. The derivative would be 2x plus what? 4. That is my derivative, okay? I want this to have a slope of 0. So am I going to plug 0 in for x, or am I going to set this equal to 0? Set this equal to 0. And then solve this equation. So we should get x equals -2. Okay? If this was a cubic function and we took the derivative, we would end up with a squared term, right? So I would maybe have two things, right, after I factor it. So I might have maybe 2 points where there is horizontal tangent line. Or maybe there are 3 points where there is a horizontal tangent line, okay? Just depending on what you get when you take the derivative of your function, okay? Any questions on finding tangent lines? Okay. Let's move on then to the new notes that are in Schoology under day 3. All right, so this graph right here should look familiar. It is the graph of sine of x, okay? The one on the right is your graph of cosine of x, okay? We want to find what the derivative of both of these are, okay? So remember, if I look at the point, the x value, right, I want to look at what is the slope at that point, okay? Then your derivative graph is your x value with your slope, right, at that point. So for example, if I look at, let's look at all of our horizontal spots here. Okay, our horizontal tangent lines to the graph of sine of x are at those values, yes? So that means the slope at all of those values is actually what? 0. So technically, I'm going to plot my point. I'm going to draw the derivative graph on this sine of x graph. My derivative would be at negative pi over 2, it's 0. At pi over 2, it's 0. And at 3 pi over 2, it's 0. Okay? What about at 0? At 0 here, if I drew a point or a tangent line at the point 0, that's about a slope of 1. Okay, it's not perfectly on there that you can see, but it is a slope of 1 there. So I'm going to go ahead and plot my derivative at 0 is 1. Okay, now let's look at the negative slope, right? Over here at positive pi, I have a slope of -1. So at pi, I'm going to have a point down here at -1. Okay, I'd say we have enough points here that we could probably draw this graph in. Okay, my derivative of sine looks very similar to what function? Cosine of x, okay? That's because the derivative of sine is cosine of x. So let's go ahead and write that down here. The derivative of sine is cosine of x. That is going to be something that you need to have memorized. Okay, that will be something that you guys will make flashcards for next class. That will be one of them. Okay? All right, let's do the same kind of thing for the graph of cosine of x. How many people think it's going to be sine of x? Yeah, you're wrong. Let's find what it is. Nope, you're still wrong. I'm kidding. Let's figure out what it is. Okay, all of these horizontal points of tangency, right? These are all going to have slopes of what? 0. So let's draw those on here. These all have slopes of 0, so I'm going to be pointing at 0, 0, and pi, comma 0, and 2 pi, comma 0. Okay? Let's look at the points negative pi over 2 and 3 pi over 2. If I were to draw a tangent line here and here, bless you, both of those values are at, or our slopes are at 1. Okay, and then we need to look at this negative slope here. We've got our positives, we've got our zeros. At pi over 2, we're going to have a slope of negative 1. Okay, so if I drew my line or my graph in here, hopefully that yellow doesn't hurt anyone's eyes. It's a little bright there. What does that look like compared to the sine graph? It's going down first, whereas on your sine graph, it's going up first, right? So what kind of reflection is happening there? Yeah, it's an inverse of that. Well, not inverse, but it's flipped over the x-axis, right? Which means if I was writing that as a transformation, where would the negative go? With the x or outside of the x? Outside the x. So this is actually, the derivative of cosine is negative sine of x. You were close. You were kind of right, but you weren't quite right. Okay? You think it's going to be the opposite, but it's not. Yeah. Okay? Okay, now we can actually go to the other notes so that we can finish those up. Okay?